Hi, welcome to this video. We'll be looking at the Shem-Prashad algorithm series, and the next couple of algorithms, as we can see, they will be on trees. So I felt we should have a small discussion on trees, what data structure looks like and how it transverses across it. The reason why I'm doing this is so that when we are talking of the algorithms, we just focus on the meat of it, which is just dealing with what the algorithm is actually focusing on. So let's say we have a tree, and this is how the tree's data structure actually looks like. It will just have a root. So we have here, we call this the root node, and it actually is the tip of it, like where all other nodes rather come and get their are attached to. So for example, if I give them, let me say 1, just for easy identification, 2, 3, and 18. So let's say this is the tree, and this is how it looks like. Now, what happens is that 1 is the root node for 2 and 3. It is the parent node for 2 and 3. 2 and 3 are child nodes to 1, as 7 and 8 are child nodes to 3. So basically, this is how it really looks like. For example, 4, 5, 6 also are child nodes to 2. So this basically is this tree structure. Now, when it comes to how you go across a tree, there are two approaches. We have the depth first search approach, and we have the breadth first search approach. Now, the depth first search seeks to go deep. Deep is what it seeks to. So that's why this is called depth, while this is called breadth. So the depth first search, like for here, it will start from 1, go to 2, go to 4, go to 18. And then since 18 has no child, it goes back one way upward. And it says, does 4 has another child? Yes, so it comes to 17, for example. It now goes back to 2 and asks, does 2 have any other child? Yes, it goes to 5. 5 has a child, it goes to 16. 16 have no child, it goes back to 5. 5 goes to 13 again. 13 has a child, it goes, and this 14 also has a child. It goes back to 14. 14 doesn't have any extra child. It goes back to 13. 13 has another extra child. It comes to 12. So this is how it will keep going till it transverses everything. So you see, it focuses on going deep first. It goes to the depth of it first before going backwards to go check another angle. But in the breadth first search, so if I have, let me just create one smaller tree here. Let's just say this is what we have. So this goes to this, goes to this, goes to this, goes to this. Now, in breadth first search, what happens is 1, 2, let's say we have 1, 2, 3, 4, 5, and 6 here. So in breadth first search, what will happen is it will go with from 1. From 1, it transverses to 2, and then to 3. It will first deal with everything on each level. So for example, it does 1, goes to 2, 3. It is done with that. It now goes to this level. 4, 5, there's nothing, it now goes to this. So that's why this is called breadth first search. You are checking the breadth of it, unlike in depth first search where you are going across it in this manner. So something like you are going downwards like this. So this is the DFS approach. But in the breadth first search, you are going through the breadth first. So you are searching through the breadth before you go down. But in depth first search, you are going down before you go to the other side, before you go wide. So, and it depends on what you are trying to achieve that you use either the breadth first search or depth first search. Now, basically, when you have the breadth first search, what it does is that in the breadth first search, let's say you have a list. Let me just have this list here, for example. And what you just do is, so at the root node, for example 1 in this our scenario here, or let me just have a smaller 3 nodes so that it's easier to explain. So let's just say we have this 1, we have this 3, this is 1, this is 2, this is 3, this is 4, 5, and 6. Now let's say we have this 3. Now what we want to do with this is that, so let me just make this one more. So what we'll be doing here is we go through it from the breadth, right? So we start with 1. So what it does is you put 1 into your list, or this your node. So this is like a queue. Imagine this was a queue. And you remember, in a queue, it is first in, first out. That is a queue. So that is exactly how the breadth first search works. It works with an idea of a queue. So the first node we are at is 1. So at the beginning we have 1 here in our queue. So what we just do is we pop out this 1. So we have node 1 here. And then what we do is we just put the children for 1 are 2 and 3. So we put those children into the queue. And we do whatever operation we want to do on 1 before we proceed. So we go again, we pop out whatever is in the, because when we pop out, you know, this the head of our queue becomes 2. Now we pop out what is there. So what we have there is 2, node 2. The children of our node 2 are 4 and 5. Those are the children of this node. So we do whatever operation we want to do with 2, and then we go back to our queue. Our queue, we have 3 now as the head. So we pop out that again. So we have node 3 here. So when we check what is in 3, 3 has 1 child, which is 6. So we put 6, and then we do whatever operation we want to do with 3, whatever that might be, before we go to 4. We pop out, you know, we pop out what is in 4, and when we pop out what is in 4, we ask, does 4 has any children? No. So we don't put anything, we don't add anything to the list. We go to 5. We perform our operation with 5. We ask, does 5 has any children? No. So there's nothing to add to the queue anymore. And then we go to 6. So you know, the head is now in 6. Is 6 having anything? Any child? No. We perform whatever operation we want to perform with 6, and that's the end of it, because at this point our queue is empty. There is nothing more in our queue. This is the approach for breadth first search. It's very important we take note of this. So let me move upward a little so that we can look at that of the depth first search. So let's say we have, like we did for the other one, we have this, we have our tree. So we have 1, 2, 3, 4, 5, and 6 here. And we're trying to use the depth first search here. Now, unlike the breadth first search, which was a queue, the depth first search works like a stack. That is how it works, like a stack. So imagine we have a stack and we put the first item. The first item we put is 1. So 1 is here in the stack. So what you do is you will have popped out what is in the stack. So when you remove what is in the stack, it means that our stack becomes empty now, and we have 1 to operate with. So 1, we ask ourselves, does 1 have children? Yes, 1 has children. What are the children? 2 and 3. So we have added these 2 to the stack. Now, but in a stack, what it does, it removes the topmost item. So what it will remove is going to remove item 3. So that is 3 becomes what is going out. And so, you know, 3 now comes out. That's what a stack will do. Whereas a queue, we pop out the first item that entered. Queue pops out whatever is the most recent item there. So we pop out 3, and then we ask, does 3 has children? Yes, it does. So we put the children into the stack. So we are done with 3. We go to our stack. We pop out whatever was the last item there. What is the last item there is 6. So we pop that out again. We have 6. We perform whatever operation we want to perform with 6. We've done that. We ask, do you have children? It has no children. So we leave it there. We go back to our stack. What is the last item there? 2. We pop it out. We pop out 2. So we no more have 2 here now. So this is no more the bottom. So this is our bottom of the stack now. So we do our operation with 2. We now ask, does 2 have children? Yes, 4 and 5. So we put in 4 and we put in 5 here. And we are asking, are we done with your operation with 2? Yes. So you go to stack again. What is the most recent item? It is 5. So we pop out 5. So what we are now operating on is 5. We now ask ourselves, does 5 have any children? No, 5 has no children. So nothing to add to the stack. and then we now go back to our stack, and the only item there is 4. That's the most recent item there that is left. It's 4, and then we pop that out also, and we ask, does 4 have any children? No. And then we'll come to our stack, and at this point our stack is empty. So until our stack is empty, we keep performing the operation, and you see it goes, for example here, it went down this way. If you look 1 to 3 to 6, before it now came to do 1 to 5. So you now see before it now went 2 to 5, that is, imagine going from 1, 2 to 5. And then it was after it finished this, it now came back from 2 to 2, and then we went to 4. So this is the depth first search approach versus the breadth first search approach. Let's look at how this will look like in code. We'll be using the Fiddle IDE for that. So here we have Fiddle, and I've just written out some code, and I'll just quickly explain it. I don't want this video to be too long, because if I'm to be writing the code while trying to explain it will take a little bit of time. So I have taken liberty to actually write down some code. So basically we have our tree class. This is our tree class. It represents what a tree node looks like, and as we see, it has a list of children, so that will determine, you can add as many children as the list we want, and then that particular tree has its own particular value. I have this create tree. All it just does is to create the tree. So we see the root node is going to be 0, and 0 we have child 1, 2, and 3, and child 1, the first child, so the first child, we have the first child, it have 2 children, and second child only has 1 child, the third child has 3 children, and then we see that the third child, that is the third child of the third child, has 1 child. So at that level, so we could say that this is top level, and then, okay, sorry, no, not there. So we could say the root is, or let me do it from here. We could say this is the top level, and then we have this as the second level, and then after that we have the third level, and we have the final level. Basically, so if I go back, I just want to draw out what we have here, so it's maybe a little bit more visual. So here, basically what we have is just, we have, so we have this, then we have this, we have this, then we have this. Okay, so it has 3 children. So this is 1, okay, sorry, 0. That's 1, 2, 3. Then we have 4 and 5. So I will have to take away this. So I take that away. So we have, this has 6. This has 7, 8, and 9, and then this has 10. So visually, this is how the tree just looks like. So we see that the root node is 0. We have 1, 2, 3, and then 3 has 3 other children, and 9 has just 1 child. So at this level, we just have 1. So let's go back to the code and see what we do. So here we see that at this level, this is what we have for each of them. Now we have the breadth first search approach, and we have the depth first search. So let's start with the breadth first search. Remember, for the breadth first search, we said it uses the queue, while for depth first search, we said it uses a stack, and that's basically what we're doing. So for the breadth first search, we have a queue. So C# has a queue class within it, so we just make use of that. And then what we just do is, at the beginning, we put in the root node, and we just keep doing this until whatever operation I want to do. So for example, I want to console log the values of each of them, and so when we go through it, we're now saying that while there's something in the queue, we want to continue working. So we've put something in the roots in the queue at the beginning. So at the beginning, there's actually something, and then what you remove what is there in the queue we do what we want to do with it, and then we now go to the children and say, okay, add the children to the queue, and it keeps going until there is no more child to print out. And so if you look here, you will see that this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we go to our table, we see it's just basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You see it's going breadth by breadth, level by level. So this level, then go this way, then go to this level before the final level. So basically that's the breadth first search approach. So but when we look at the depth first search, it's a stack and we keep pushing to it. So when we have a value, we push to it. So for example, at the beginning we push our root node, and then it subsequently keeps popping out, and then we push the children too. And if we look at the output from that, we see that it's 0, 3, 9, 10. So if we look at the 0, 3, 9, 10, and we go there to see what we have, you see 0, 3, 9, 10. You see it's going through this depth like this. It's going to the depth before it now goes back again. And then if we go back again and we look at what we have there, you'll see that we have, after that we have 8, 7, 2, we have 6, 1, 5. So 8, 7, if we go back to look at that, you see we have 8, because this is the only one on this level, because you know at this depth it has already done 0, 3, 9, and 10. So when it comes back, it has done 3, it has done 9, it has done 10. So it comes back up, and then at 3 again it goes back to 8. It comes back up, and then it goes back to 7. Then we now go back to 0 because we are done with all of this. It goes back to 0 before coming to 2. So you now see 8, 7. That's why you now see 2, 6. It goes through this depth also. So you see it keeps going for each time part it goes down to the end of that part before it returns again. And you'll see that the last item there will be 4, because that's going to be the last item that it will reach out to. So if we go back there to check, we see that actually the last item there is 4. And basically that's the depth first search. And as you can see, it depends on the algorithm you are solving that you use one. Although you could use any one, but they are best suited for different scenarios. So for example, if you have to be checking for the levels of which operations are done, I think that the breadth first search will be best, because it groups the levels together. So for example, we know that this is the top level, 1, 2, 3 at the next second level, 4, 6 all the way to I think 9 at the next are all in the third level, and then 10 is in the last level. So you see it kind of groups them together. But if maybe the depth is what I'm actually after, then going with the depth first search will probably be the best approach. I hope this was clear, and I hope we've been able to do justice to what a tree is as simply as possible. If you still have any question, please drop them in the comment section and I'll be there to respond. Please like, share, and do subscribe, and I'll see us in the next video.